Hello, everybody. Welcome back to
Hello.
another round of OAuth Happy Hour. If you are joining us on Twitch today, we should be able to see comments there as well. And we're also broadcasting this on YouTube, where it will be available for watching later, as always. So come with your questions. Bring your questions. Feel free to ask us anything about OAuth or web security, but we'll also be sharing some updates about what's been happening in the OAuth world.
It's always a good place to start.
Yeah, sure is. So I guess let's just dive right in. And I realize I should share my browser um, with the stream so that you can see what I'm talking about. This one.
Nice.
This is the list of active documents in the group. And you might notice there's a couple of updates recently. This one and this one. This one's still got a little new flag on it. This one's still pretty new, I would say. It's less than a week old. I feel like they should leave the new flag on there a little bit longer. So what's new is these were about to expire, and they had a bunch of pending updates that both the authors of all the documents were have been talking about over the last now several months. They expire every 6 months unless there's an update, and then that bumps the expiration date out. And in the last 6 months, we've had several OAuth working group meetings and lots of discussions on the mailing list, also in various other channels. And there was a lot of sort of outstanding changes that had been discussed that hadn't actually made it into the document yet. So that's mainly what that update is. If we take a look at these, I think they both have change logs in them. Document history. So this is the one for browser-based apps. The changes here, there's some, again, language clarifications around PXE requirements because of wanting to allow OpenID Connect clients to not have to do PXE. Although now that I'm saying that, I think that was one of the things that was in flux. Let me take a look at this document history
I thought
here.
there was already some specific language around that to constrain it to that, specific use case with OpenID, like where you have a nonce.
Yeah. So that was in the security BCP.
Oh,
And now I'm looking at this and realizing that I think I missed a step in the discussion when I did that update because the security BCP recently updated to say PXE is a must for public clients, which of course browser-based apps are. Which means I need to go back and change this. What was the actual diff? This is how you can see what changed. I rephrased this because this was one of the changes as well. Rotating refresh tokens is, I think this should match now. This one says, oh, there was a change about how it referenced sender constraining. But the idea with rotating refresh tokens is that sometimes deployment situations make it difficult to rotate, and we wanted to leave that up to people still.
so it's a should now
So
instead
it's
of
a
a must.
yeah. So here's the text we were talking about the PXE change.
Right,
So this is here. Talking about
right.
the use of the nonce to protect against injection attacks only works if the client properly checks the nonce.
That is an important point, and one of the things I try to stay away from is, as a developer, leaving that sort of stuff up to me and my client application programming. I'd much rather the authorization server handle it for me.
Yeah, I would much rather just have that be enforced at the server level where the developers don't really have to worry about it because it will not work unless they're doing the right thing, as opposed to look like it's working and then have a security hole. So yeah, these were two recent updates. There's still more work to do on these. There's more discussions that have happened that didn't make it into these edits. So these were just sort of incremental updates, mainly because they were running up against the deadline and have been a while since they had been updated. I think, let me look at the dates of the other ones. I think that's the only other things in the last couple of weeks that have been updated. Yeah.
And are they now extended because of the updates? Is that how the process works, or you?
Yeah, exactly. So every time a draft is published, the expiration date is 6 months from that.
Got it.
Yep.
I'm curious to know. I don't mean to put you on the spot, but I notice your implicit flow detector in your browser was red. Was that one of our sites that it caught, or something out in the wild?
Oh,
We have some
actually,
examples that still use the implicit flow on purpose.
no, this is, oh, funny. It's not sharing that in the
Oh,
screen
it didn't
share.
share the pop-up. Interesting.
That's really funny. Let me switch to share my actual screen then, because that I was just sharing the browser window.
Uh,
It was ExampleApp.com, which
oh,
is my testing site for when I do workshops. I use ExampleApp.com as a redirect URL. There's a bunch of stuff on here, but one is redirect. And if there is a code in the query string, then it will like say, yeah, congrats. Here's the code. Here's the state. You should verify the state. And then the idea is like during the exercise, you would copy and paste this into your terminal to make the post request to the token endpoint. It means that there's a redirect
right.
URL you can use that's actually like somewhat helpful instead of redirecting to something that doesn't either doesn't exist
Yeah.
or doesn't know
Just get a
what to do with it.
browser error or something. Yeah.
Yeah, and then there's also if there's an error, then it will show that as well.
Oh, that's cool.
So it's helpful to return that. But I was using that to demonstrate all of the different OAuth flows, including the implicit flow. And I need to write some code to actually handle this, like to display it. I don't have it displaying stuff in the fragment because I have to do that in
Right.
JavaScript. Um, but that was the thing that was caught by the implicit flow detector because I was demonstrating the implicit
Neat.
flow.
All right. The system works. And it's got the little yellow flag because it was just an ID token and not an access token,
Oh, is that
which
what
would have
that
been a
means?
red flag. Yeah. If it catches an access token, that little arrow flag is red.
Got it. Yeah. Yeah, cool. I am looking forward to making more little tools like that to help people learn about OAuth. Might be able to do it
Yeah,
also on
handy.
OAuth.com. I can probably can I reset this? Yeah, reset.
Yeah.
If I demonstrate the OAuth implicit flow using the playground, which is a fun little. This is now completely fake, where it didn't actually do anything. It just generated these random strings and stored them in the browser.
Neat.
But we've got a fake user account here. And now if we do the flow, here is response type token. Here is the client ID that it generated. Here's the redirect URL. And if we click authorize, it's going to actually redirect to a fake auth dialog with all the parameters in the URL. And now we have to actually log in. And you do actually have to enter the right password, even though it's fake.
Nice.
Forgot your password opens up that window. Just
That's a
shows you the password in case you didn't
that's a
pop that up
nice
ahead of
touch.
time. It just opens it up.
Yeah.
It's like, well, here's your password. Uh, Not a realistic forgot password flow, but that's not what we're demonstrating here.
Yeah.
And then if I redirect back, okay, it's giving me the consent screen, approve, and it redirected back with the access token, which turned this icon red because it found an access token in the URL.
Neat.
So the idea here is you're supposed to match, does the state, this is one from stored at the client, this is the one from the URL. Yes, it does match. Continue. here is the access token, and now you can use it. You're done. I don't have a fake API to,
To use the access token.
yeah, I don't have anywhere to actually use the access token, but maybe I'll do that later.
All right. That's cool. I'm always trying to catch the implicit flow in the wild. I've caught a few now and notified, website maintainers and things like that. But
Have you got any
I like to
responses from
see it when it
those?
happens. Not a single one.
Okay. Could be either they don't want to admit it or confirm it, or they are just ignoring it because they don't understand.
Or they think I'm phishing, or who knows. Like whenever you
Right.
get an email that says, "Hey, you have a security problem," even though it's, my official Okta email and all that, I would be suspicious of that too. But I would
Yeah.
follow up, I think.
I've actually been getting emails from random people who are clearly going through some list of like known vulnerabilities and finding like a GitHub project of mine or like my website or something, and then email me and say, "Hey, we're filing this CVE, or here's how you can look at the details of this vulnerability." And I'm like, okay, first of all, this GitHub project is like 5 years old. I really don't care about it. It is not actually active. Or it's like I have like some of these other test websites that do things that normal websites probably wouldn't do. Like actually, the ExampleAppcom is a good example where this is a classic thing that it can be used to pull off various attacks where stuff in the query string gets written onto the page. So if you can like, I hope I hope I don't. I hope I escape this. We'll find out in a second.
Yeah.
Yeah. But like if you don't escape that properly, right, then that gets written into the page, and
Right.
then you can inject JavaScript, which means I could send this URL to somebody, which would then run that JavaScript. So it's that's the kind of thing that like automated scanners will flag, or even I've had sometimes the browser itself flag that because it is
Oh, that's cool.
technically not a good idea to do that, but I feel like it's
Right.
fine for this purpose.
Yeah.
This site
Yeah,
doesn't
you run
actually do
into
anything.
I always get excited when the implicit flow detector goes red in my browser, and then I realize I've just visited my own site that shows the implicit flow as a bad example on purpose, and it just got caught. But
Yeah.
we have a question that's
Yeah.
related to that.
Yeah. Is the implicit flow considered bad or just some implementations? Both. The implicit flow for getting access tokens is considered bad. And that's the thing that the implicit flow detector is pointing out. The idea there is that it's specifically that the access tokens are issued in the redirect response rather than from the token endpoint. And because they're issued in the redirect, they're available in the URL. And there's many more ways that that can be stolen at that point. And there's no confirmation that the application has actually received the access token. Whereas when the authorization server issues the access token from the token endpoint, it can protect it with either client ID and client secret or PXE, where it actually knows it's being delivered to the correct application. So that confirmation step is missing when issuing access tokens via the implicit flow. Now, the some implementations part is if you are doing just OpenID Connect and you're not issuing access tokens, if you're only issuing an ID token with the implicit flow, then the risk is, first of all, very different if something is broken, if it is like, if there is a vulnerability, then the risk is that the ID token is stolen, which basically means the attacker learns who the user is. So like not that big of a deal, although sometimes it could be. Up to your implementation to decide whether that's too risky. But the applications can prevent injection of ID tokens by using the Nonce. So that's how the application can protect itself against. There's two sides of the equation, right? The The application is receiving data, which means the application can't trust it until it's confirmed it. And the authorization server is sending data, which means it would like to be more confident about who it's sending it to. And both sides need to protect themselves in this flow, right? So the nonce is the client protecting itself against accepting ID tokens that were not intended for it. So the application starts by making up a random string and then looking for it in the resulting ID token. Because if someone tried to inject an ID token, it wouldn't have the correct nonce, or the signature would have failed. But in that exchange with just the implicit flow, the authorization server has no way to know that it was delivered to the right application. I've actually been using a new analogy for this in my workshops. And I don't think I've told you about this yet, Micah. So
No, I don't think so.
I realized that a better analogy for the front channel is actually treating the front channel like a courier service, like a package delivery service. So if you ship a package, like if I'm trying to ship you a package right now, I can't hand you something in person, right? Because we're pretty far away from each other. So I would have to ship it in the mail. Now, if I pay UPS to deliver a package, I'm reasonably confident it will get there, right? Like, it's got a tracking number. I can see if they say it's been delivered. And I'm reasonably sure it'll get there because I am paying them. It is a service they're providing. And we generally trust it. However, I have no way to actually know if you got the package until you tell me somehow. And also, I would have no way to know if the package has been opened up and the contents have been tampered with on the way. So I don't know that. And then on your end, when you're receiving the package, you get a package that has my from address on it, but you can't actually be sure that it's really from me, because anybody can put my from address on a package and mail it to you. And you also can't guarantee the contents weren't tampered with. So I like that because I feel like it's a little bit closer to how we treat the browser, where we generally trust it to do the right thing. Like everyone's kind of, we know the browsers mostly work most of the time. And when something goes wrong, a lot of things fail and break down, right? But generally they work. But yeah, like you have that problem of it's a handoff. You've handed it off to the browser to deliver to the other end. So the application is trying to send a request to the authorization server about what it's trying to do, like the scope and all that stuff, right? But it's sending that request through the browser. So there's the first package. And then the access token, or the response, which is in the implicit flow, the access token, the response is coming again through the browser. The authorization server ships it through the browser back to the application. So you're kind of missing that visibility. So what we need to be able to do is use the front channel, but have a way to confirm that it was successful. And that's what adding the authorization code step does. So if you're trying to send me an access token, instead of sending me the access token, you ship me a package with a temporary code. And that code can only be used once. And then when I get that code, I then call you on the phone and talk to you directly. And I say, hey, here's this code. Is this correct? And can I now please get the access token? And then you can tell me the access token in person, right? And that way, the use of the front channel, if it was compromised, it doesn't matter anymore, because you wouldn't tell someone over the phone the access token because they wouldn't have the client secret or the Pixie secret. So anyway, I like that.
I like that analogy a lot too, because it can open up a conversation for, well, how would you definitively verify the package? How would you try to? And in probably most cases, you'd fall short of, something like directly handing somebody something. You could try to enclose something in the package that you verify. That could kind of be like the nonce, but like a lot of different methods might break down or might be complex. So it's a good analogy on a bunch of fronts. I dig
Yep.
it.
Yep.
I wonder, I just had this thought about making a new browser extension for research where it intercepts the flow and purposely changes the nonce to see how many applications
Mm-hmm.
actually catch that. Same thing for state. It'd be
I mean,
interesting. I know
at this point, you're talking about making a testing suite, which is super
right?
useful. Yeah.
Yeah, getting close to that. But I know our JavaScript SDKs, by R I mean Okta's JavaScript SDKs do those checks for you, which is a nice thing for developers. But you and I together have seen some instances where, some pretty well-known sites were not checking state even, and you could just, you know,
Yeah.
steal the code and use it.
Yeah. Speaking of, let's talk about state versus nonce.
Yeah.
So the state is an OAuth concept, and it's actually gone through a couple of iterations now. And the original goal of the state was for CSRF protection, essentially. And that is the way that works is the app starts by making up a random string, and then when it sends the user off to the OAuth server, and the OAuth server sends them back with that temporary code, the app has to check that that redirect also contains the same state value. And the theory there was, well, let's not make an endpoint on the internet that accepts an authorization code in the URL and then tries to exchange it unconditionally. We should at least have one layer of protection there so that someone can't get tricked into visiting that link without starting the session themselves. So it basically forces the application to create a session in order to store the state, which is then able to protect against CSRF attacks. Now, that's how that started. Pixie was developed later, and Pixie also prevents CSRF attacks. And it does it by, instead of the application having to do any work or any effort about it, the server prevents that from happening. So once you're doing Pixie, and if you know your OAuth server supports Pixie, then you actually don't need state to be random anymore. And you actually can use it for the other purpose that state was created for, which is storing application state, like where the user
Where you
came
came
from
from.
before they were trying to log in is a very common one. Like they were on the shopping cart, so let's take them back to the shopping cart after they log in. Or they were on their account settings page, or actually that's not realistic. How could you be on your account settings page? Shopping cart versus like a product page or something. So we'll take you back to that where you came from when you started logging in. Nonce is a OpenID Connect concept. And we talked about Nonce a second ago, where it's actually very similar to state, but it's meant for protecting against injection attacks or CSRF attacks, where again the app makes up that random string, and then it's expected to find that string in the resulting ID token rather than just in the redirect. And that's because in OpenID Connect, these tokens are meant to be read by clients, so we can actually put information in them that the client can read. So Nonce is an OpenID Connect thing. It's not at all part of OAuth because it's part of an ID token.
That makes sense. The big difference being that state ends up being outside the JWT as part of the URL, and the nonce ends up coming back inside the JWT. So you have the benefit of verifying the signature to know that it hasn't been tampered with, and then you can compare it against the original value.
Yep. All right, looking through the questions here. This is a good one. Is there any reason that MutualTLS is in draft? Can we implement holder of key access tokens use case? So I thought actually that MutualTLS was out of draft stage. So you may have just been on a old link because they do get RFC links after they're published. And trying to find it. OAuth MutualTLS. Yeah, okay. It is RFC 8705. It was previously a draft up until, so August 2019 was the last draft. This was published in February this year, ages ago. So this is a RFC now, and this is one way to implement the idea of sender-constrained access tokens, which is the current terminology for that. I think holder of key is a SAML technique, if I'm not mistaken, but it's all the same idea. The idea is that a bearer token, if that's not enough security for you, because a bearer token can be stolen and used by the person who stole it, if that's not enough security for you, you want to do some form of proof of possession or sender constraining. Those are the two terms, two different terms thrown around. And there's any number of different ways you could do this, right? The idea is you probably want some form of public key cryptography involved so that the key never actually leaves the device and it's only just signatures getting exchanged. So you want some way to issue an access token plus tie it to some sort of certificate somehow. So MutualTLS is one way to do that, where it's done at the TLS layer rather than in the application layer. And that is now an RFC. There are some people who are not happy with the idea of requiring MutualTLS as the only way to do this. So there's other attempts being done to work on this problem as well. And the reason that...
Is one of those Depop, or is that a totally different?
Yeah, no, that's exactly one of them. So that one's a new draft.
Yeah.
That's doing it in the application layer. So that means your application code has to actually be written to deal with the keys and signatures and stuff. At the TLS layer, you do it in your HTTP client. You configure it with a certificate. And that's sort of the reason that some people don't like it, because it requires HTTP client support, which not all of them have that feature built in. Most of them do, but not all of them do. And it's harder to deploy on the server end because you have to have the ability to check the client certificate at all of your endpoints. So your authorization endpoint as well as your resource servers. Those all need to be able to handle and validate the TLS certificate, which when we're talking about a more distributed architecture of your authorization server might be a completely different, on a different host name or different server from your resource servers, it's harder then to get them all to share and coordinate this validation process. And once you start adding like load balancers or things that go back farther in the chain, again, it becomes more challenging to deal with. So there's attempts to solve this in different ways as well, Depop being one of them. So the Depop idea is, again, it's public key. So the client makes up a key and then makes up a private key. And then every request that the client makes, it creates its own signature and puts it in an HTTP header. And the signature is across some number of the HTTP headers and the payload. Actually, may not even include the payload. So there's a list of headers that you have to sign, and you sign it with your key. And that way, when you, again, when you make a request for a token or to a resource server, it has to validate that signature. So it's just all done in the application code, not at the transport layer. So there's trade-offs to both, right? Because it's sort of cleaner keeping it in the transport layer because it means the application code doesn't need to be updated, but it does mean your transport layer needs to support it. Whereas moving it into the transport layer or moving it into the application layer means you can do it from a browser, for example, where there is no ability to attach a certificate to requests. So trade-offs, but those are the two that are active. MutualTLS is an RFC and Depop is very early draft still.
It's a good question. For NodeIDC code flow with Pixie, is the nonce needed? That is maybe debatable, but it is required, right?
Yeah, the OIDC spec still requires it because OIDC was written before or was published before Pixie was finalized. So OIDC assumes you're not doing Pixie, so the language is always going to require nonce. As far as what it actually does, if you are no, so if you're doing this over, if you're getting your ID token using Pixie and you're getting the ID token from the token endpoint, then you don't need to even verify the ID token signature. This is one of those sort of weird things where the reason that ID tokens are JSON Web Tokens and that you have to validate the signature and validate all the claims, including nonce, is if you're getting it over an untrusted channel, like the front channel. So when you receive it over the front channel, it's like it came from a package delivery service where you're like, I don't know if I really trust that this package is from this person. Let's go and verify. And let's also verify that I requested the package, which is what the nonce is doing, right? It's saying, yes, this is the package I requested. Because when I placed the order, I put in this nonce into the order form, and then I got this package with the nonce printed in it, right? So it's a way to confirm that you requested that package. And with Pixie, if you're getting the ID token from the token endpoint as well, you're getting it from, it's like walking up to a service counter and asking for the token right there, where you already know who you're talking to. You're not getting it from the mail. So you don't need to verify the signature. You don't need to verify most of the claims. You can just treat it as basic C4 encoded JSON data and just extract the parts that you need out of it. So yeah, I don't think nonce does anything for you if you're using Pixie and getting the ID token in the back channel.
But it is required by the spec.
But the
So
spec will
it's
still
got
say
to be in there.
required.
Yeah.
So I guess there's a possibility here that OpenID Connect may publish a revision after OAuth 2.1 is finalized and done to sort of update the OpenID Connect guidance to do things like remove all the hybrid response modes that include token, because we should not get tokens from the authorization endpoint ever. And then it could also do things like drop the need for nonce if you're using the back channel flow, if you're using response type code rather than response type ID token. There are still reasons that you may want to use straight up response type ID token and only get an ID token only in the front channel and not get access tokens at all. Like, that is a valid use case. And in that case, you absolutely do need to use nonce and validate it. But I'm lazy, so I like to not have to bring in JSON Web Token libraries and deal with cryptography. So I just use Pixie and get everything over the back channel.
Easy peasy.
Yep.
Nice.
Philip heard a rumor of a Udemy course. How's that going? I'm in the middle of it. I'm in the middle of filming and editing, so it is still going. I was actually just editing the ID token discussion yesterday, so it's fresh.
I thought you were going to be coy and say I can neither confirm nor deny. But in
no,
process.
I don't have any reason to hide it, but it's not done, and I'm not going to commit to a date either. So
Smart.
Yeah. All right.
What else you got?
The rich authorization requests is a fun one. That is still in progress again, and it's a very cool idea for when scope is not expressive enough. So if you are trying to request access to, for example, specific resources rather than generally the concept of like someone's photos or someone's email, if you're trying to request access to a specific photo or a specific email or authorize a specific transaction of moving a certain dollar amount from one account to another account or something like that, that's what rich authorization requests is for. I know that it's being used in the financial API space, and I haven't been following like implementations over there too much, but I do know that is where it is. That's where it came from, and it's just getting brought into the OAuth group. So I assume that there's implementations over there with those APIs. But as far as the OAuth group, it's still a draft, and it's still working its way through that process. We're up to draft 2 now, published in August. Last update was August. I don't actually remember what was new. Clarified type parameter processing. Okay. I don't remember the details enough of that to know what that means. We can see if we can find the diff. This is the change. Type. This may define what other elements are allowed in the request. That's the same. Oh, so there's this paragraph added. Exact byte match of the string value against known types. Huh. I don't remember the discussion about that. Anyway, here's a good question. In what circumstances is it appropriate to use the state parameter as a relay state to direct the user to specific pages? If not appropriate, what is the recommended solution? Cookies or browser storage? So you can always use state for this purpose if you also include a random value in the state. So the state value, so if you're not using Pixie, then you have to include some random value in the state parameter. Otherwise, it would be possible to trick your application into accepting authorization codes. So you could use it for example, like 8 random letters and then a colon and then your sort of redirect bit, right? Make up your own encoding scheme for that. That's fine. Another way to do it is to use a JSON Web Token as the state value, where you could, that'll have enough randomness in it because it'll be signed, where the signature would change depending on like the timestamps that you put in there, for example. So you could use that, and then you would validate the signature before you then process the value.
There was a proposal for that at one point that I think expired, probably because it kind of is already, there's no reason why you can't do it already, so maybe it didn't need a whole separate spec or something.
Yeah, I'm trying to find it. It's JSON JWT no, I can't find it.
It's encoding claims in the OAuth state parameter.
Oh, where'd you find that?
I just put the link in.
I can't click it.
Oh.
It'll show the comment, but I guess we can show the comment anyway. I just still can't copy the text. Why is that not in the list? JWT encoded state. Nope, no idea. So yeah, the idea there is that it's a formalization of that. Like you can just do this. You don't need a spec to say that you can. You can just do it right now. But the idea with a spec is that it is a formal and consistent way to do it then. But I guess there wasn't enough interest because it kind of just dropped off.
Yeah. There are all kinds of mechanisms that are already there for managing application state in a stateless kind of flow. You know, you might have a cookie or a Redis store, or, you know, there's all kinds of different ways that people have already handled that. But I never thought of the point that you're making, which is that there's no reason, as long as there's some sensible amount of randomness in the state, you can tack anything else onto it that you want with some sort of separator. That's kind of a cool idea. I never thought of that.
The one caveat I will say is do not let yourself create an open redirector. And that is the idea of an endpoint that will redirect people to arbitrary locations. So if you do want to have the ability to use like this sort of simplified state where you do like a little bit of random string, a separator, and then something telling where to redirect back to, that needs to come from an explicit list in your code and should not allow people to craft URLs that can send people to arbitrary locations. So don't accept full URLs, for example, in that, because then someone could create a link which would send people from your application to arbitrary URLs. So it needs to be from an explicit list. So relative paths,
someone like me will write a browser extension that tacks weird stuff onto the valid state.
Yep. Yep, exactly. And so that's one option. The other part of this is if you're using Pixie, you don't need state to be random anymore. So you can just use it for that. But also, if you're using Pixie, then you're going to end up storing stuff in a client-side session because you need to store that Pixie code verifier or the secret that you generate. So you're going to have a client-side session at that point, or a cookie or whatever it is. Like you need to store stuff in the client, which means it's probably easier to just store the redirect in that as well. I guess the one downside there would be the multiple tab issue. So if you want to support like people using multiple tabs all at the same time, where you may end up with them going through multiple OAuth flows in multiple tabs, you wouldn't want to clobber the redirect by you storing it in the cookie. So moving it into the state means it'll work in each tab independently. Lots of options though. The other reason for JSON Web Token state is it means that you can avoid needing to do stuff with cookies entirely. Because you can actually store anything you need then about that request in the state value because it's also signed. And that means you can't store the Pixie value because it would be visible, but you can store everything else you need about it, like the redirect or other application state that you care about, and you would be able to avoid storing it in a cookie because the authorization server brings it back in the state, and you can verify it by verifying the signature.
Yeah, it was a cool concept. I guess it just wasn't didn't get any kind of traction. Sometimes things die on the vine because there's just not enough interest or momentum for it.
Yep. That's how it goes.
I have a question related to the kind of ideal of one-time use refresh tokens. And is there any consideration in the specification given to using it in a parallelized environment, or is that entirely left up to implementation?
This is actually an active discussion right now. So there's a thread going on the mailing list right now, which I started a couple days ago asking about this. So let's back up. Refresh token rotation. The idea is that every time a refresh token is, every time a refresh token is used, a new one is returned, so that the refresh tokens are used only once, one-time use refresh tokens. So you can call it one-time use, or you can call it refresh token rotation, same thing. So the idea is that it prevents an attacker from stealing a refresh token and then using it and having that attack not be detected. Because if the same refresh token is always used, then if an attacker can steal a refresh token, then both the attacker and the real app can keep using it to get new access tokens, and nothing can tell that that's happened. So by rotating them, if an attacker steals one and then uses it, and then the real app uses it, it's been used twice, so you can detect that there's an attack and then shut everything down. The question is what you said: what happens when the real application is running parallelized for some reason and may actually legitimately use the same refresh token twice because it can't coordinate with itself? And there's multiple reasons that would happen. A mobile app, for example, may have a UI thread and a background syncing thread where they don't really coordinate. I mean, you could make them coordinate, but they don't by default coordinate. So you may end up with both of them trying to use the refresh token. Another one is multiple browser tabs, which is a real problem because there isn't really a good way for those to coordinate with each other. And again, they may be having multiple tabs try to use the same refresh token. So this is the current discussion. And this is the question the question I asked on the list was, what do people do right now? Like if you have implemented rotating refresh tokens, what have you actually done to because of these problems. And Auth0 replied, Vittorio from Auth0 replied with, Auth0 has implemented a configurable grace period, that's what they're calling it. So a grace period where it is allowed that a refresh token is used more than once. So you can configure that in your application. So you can configure it to 0 if you want to be strict,
right?
But you could configure it to 30 seconds as well, for example. The trade-off here is that if an attack happens within that grace period, it's not detectable, right? But it does prevent like a refresh token from being stolen and then used 5 minutes later. So leaving that up to the decision of like your own policies is, I guess that's the theory there, is like you get to decide what your risk tolerance is compared to how strict you're going to be about crafting your, like architecting your application. So that's one of the options, but yeah, that's an ongoing discussion right now. So we'll see how that turns into guidance in the spec. Because I do feel like the spec should at least address that problem and explain the options, even if it's not going to require an option.
Right. Yeah, I guess ideally, in an ideal world, it would be one-time use only and always detectable, but that may end up being a should rather than a must.
Exactly, because there are some practical deployments where that is hard or impossible. Here's a good question. It seems convenient to send a signed ID token to other services as it contains user information and is proof that the user is authenticated. I assume that's if this is not the recommended way. Could you elaborate on this? So the idea here is this is actually very commonly done if your client is broken up into a bunch of different parts. So if you imagine your client is actually split between a front end and back end, which is a very common pattern, right? You have a single page app front end and a back end service that is part of that client that serves the front end and then also might do some work. And the hard line to draw here is don't use ID tokens as access tokens. Don't try to make API calls with them. That's not what they're for. But it's okay to use them within the client, even if your client is distributed into multiple parts. And it just means that if your, for example, browser sends an ID token to its backend for that application, it must then be verified. Like you have to do the signature validation because it's coming from the outside world. You can't shortcut that because you are accepting the ID token as from the outside world. So that is a common architecture, and that is fine to do that. But you have to define where your so I always talk about these roles in OAuth, where we've got like the client is a role, the user agent is a role, the client is a role, the authorization server and the resource server. Those are defined because the security model of everything is defined around those roles. So figure out what is your resource server. That's usually going to be an API. And don't ever let that deal with ID tokens. That's not what it's for. You need an access token to talk to the resource server. And then whatever your client is, whether that's a mobile application, which is just code running on a phone, or if it's a single page app served by a web server that might also be doing some sort of work itself, as long as it's not your resource server, that is where the ID token can be shared around.
So it sounds like you have to define the boundary of what constitutes the client in your case, and that even if that's a cluster of disparate machines or services, that's fine, but the ID token shouldn't go outside that boundary.
Yeah,
Does that sound like an accurate? Yeah.
Yep. Cool. Back on refresh tokens. Refresh token returns from rotation should have a limit lifetime for all of its refresh token family. Yes, that's correct. So if you're, this is, so it's, again, refresh token lifetime policy is totally up to you. Like it's your call. But whatever your policy is, rotating the refresh token shouldn't break that policy. So if you say refresh tokens are valid for 24 hours, that does not mean that the new refresh token you get is valid for another 24 hours. It should end at the same 24-hour period. So it's just, so each one will be valid for less and less as they get rotated towards the end of the lifetime. But again, it's like, if your policy is that refresh tokens are unlimited, then right, it doesn't matter. It's up to you to decide that.
It does make the concept of unlimited refresh tokens maybe a little less scary because you have this rotation mechanism.
Yeah. I actually really like what Okta did with unlimited refresh tokens, which is that you can set it so that they expire if they're not used. So you can say it's unlimited refresh token, but you have to actually use it every day, for example. And if you don't use it for a day, then it does expire and the user has to log in again. That way, if the user is using the application constantly, they never have to log in again, but it prevents some of the risk of having unlimited length refresh tokens.
Yeah, I like that approach too. The example I use in the workshops is I'm adding some app that you use pretty regularly, but then you go away on vacation for 2 weeks. As a user, it's not a degradation in user experience for me to have to log in after not having touched the app for 2 weeks. But under ordinary use, I wouldn't have to keep logging in. So it's a pretty good balance I think we struck there.
Yeah, I like it. Cool. Well, a lot of good questions today.
Indeed. So next one in 2 weeks?
Next one in 2 weeks. I'm trying to think. I think, we did just schedule the next OAuth working group meeting. So that is November 2nd. We're doing these virtual interim meetings instead of meeting at IETF, because at the IETF meeting doesn't really mean anything anymore because it's all virtual. So instead of scheduling these during IETF, these are getting scheduled on their own. So this is the agenda for the next one, November 2nd, talking about the new work that browsers are doing around anti-tracking. So that's the whole like cookie apocalypse where the iframe refresh trick is not going to work anymore across domains because browsers will stop sending cookies in iframe requests across domains, which is how they're preventing a lot of the ad tracking from working, which is generally good for the web. So it just happens that a lot of the OpenID Connect stuff was built that taking advantage of that mechanism as well. And then there's a couple of new APIs browsers are working on for adding authentication as a first-class citizen in the browser in some form. So a lot of interesting implications there. And we talked about some of this stuff during the security workshop a couple weeks ago, but that was an unofficial meeting, and this is now officially bringing it to the group, talking about how it's going to impact the group and whether the group should have an official position on these and how we can get involved in making sure the browsers are building things that are useful for OAuth instead of breaking things in OAuth. So cool. That'll be a fun session. And it's an IETF meeting, which means it's open to any member of the working group. And to become a member of the working group, you just say that you are and join. So feel free to join.
Nice. Can't get more egalitarian than that.
Yeah. Well, I want to wrap up here. I have a minor emergency to deal with here, so let's go ahead and it'll be fine. But we should wrap up because I have to go answer a bunch of emails and possibly get on the phone. So this has been a good discussion. Thanks for all the questions, everybody, and we'll come back and do another one of these same time 2 weeks.
2 weeks. See you then.
All right, see ya.